We are going to be proving the geometric series whereby we say the sum for the geometric series is equals to a, which is the first term, into 1 minus r, which is the common ratio, to the power of n, which is the number of terms, close brackets, divided by 1 minus r. So for the first step, we are going to say the sum for the geometric series is equals to the first term, which is our value of a, plus, and then in order to get the next term, we have to multiply by r. So a times r is going to give us a times r all the way to the fourth term, whereby the fourth term is defined by a times r to the power of 3 up until the last term. And in order to get the second last term, we're going to subtract 1, which will give us a times r to the power of n minus 2. And then for the second step, we are going to multiply the first equation. This is our first equation. We're going to multiply it by r, which is our common ratio. And then Sn multiplied by r is going to give us r times Sn equals to a times r. We're going to get a times r, which is ar. And then you write it below the ar, which is the second term for the first equation. And then you do the same for the third term, the fourth term, up until r is equals to, up until where you have a is a times r to the power of n. And then for the third step, we're going to say the first equation minus the second equation. That is where we say Sn, which is the first equation, minus r Sn, the second equation, is equals to a minus ar is going to give us a minus 0 is going to give us a, and then this is going to be 0, this becomes 0, and this becomes 0, this becomes 0, also this becomes 0. They cancel each other out up until we have 0 minus a times r to the power of n, which will give us a r to the power of n. And then for the next step, we're going to take out a common factor. The common factor here is going to be Sn, and then in the brackets we are going to be left with 1 minus r equals to, and then a is also a common factor for these two terms, so we're going to take out a, and then we are left with 1 minus r to the power of n. And in order to solve for Sn, we're going to divide both sides by 1 minus r, divide by 1 minus r, and these two will cancel each other out, and we're left with Sn is equals to a into 1 minus r to the power of n divided by 1 minus r. And that is your proof.